Hi, I'm Kate.
And I'm Madeline.
And we're from Hillcrest Middle School. Okay, so let's just say you're at work or at the mall or at school, and there are 4 recycling bins in front of you, and you have an object, let's say a water bottle, and you don't know which bin it goes into. So if you move over here, this is a mini computer called a Raspberry Pi, and on top of it there's a camera. If you put the water bottle in front of the camera,
and click the button Scan Object, it'll take a real-time photo, allowing me time to adjust the object, and then it'll take the picture. So now it has the picture. It's going to process the image and determine what the image is of and which bin that object goes into. So now it has the object name and the bin name. It's going to light up an LED, like here, and
it will also say it on the screen.
Hi, my name is Joyce from Hillcrest Middle School. So my project is about ocean acidification and how it affects marine life. So ocean acidification is a byproduct of climate change. So when carbon dioxide is released into the atmosphere, some of it goes into global warming, and some of it is actually dissolved into the oceans, and the oceans convert that carbon dioxide into acid. And I explored how that acid affects shellfish and what it would be like in 100 to 500 years from now. In my control jar, which was just regular seawater, the shells remained relatively the same. In my slightly acidic seawater, which is predicted to happen in about 100 years from now, I noticed some bleaching at the edge of this manila clam, and also the protective covering was lost in this varnished clam here. And in the very acidic seawater, which is predicted in about 500 years from now, I noticed major bleaching in the manila clam. This varnished clam's protective covering is almost all lost.
I'm Aisha, and I'm from Coquitlam Middle School, and this is my project. For my project, I did it on radiation-powered spaceships, and basically during the 1950s there was this idea to power spaceships by exploding nuclear bombs behind a spaceship, propelling it through space. It was cancelled because it was dangerous. My idea was to make it safer. And basically, my form of radiation is decayed uranium, because uranium by itself has unstable isotopes, which makes it radioactive. And when it is depleted, it becomes more radioactive. So basically, how it will work is there would be a trigger in the controls, which would basically set off a conventional explosion in the starter. And it would go through hollow decayed uranium, which would make the conventional explosion radioactive. And radiation, it basically spreads extremely fast, which would increase the velocity. And when it would hit the top mechanism would spin counterclockwise in a spiral, going forward and launching it to space.
Hi, my name is Chelsea. I go to Coquitlam Middle School, and my project is called Violin String Swap. So what my big question is can the violin E string be replaced with another string material and still sound the same? So the 3 strings I used was copper wire, elastic string, and fishing line. My hypothesis was that the fishing line would work the best because a guitar string and a violin string are under about the same amount of pressure, and on a classical guitar there's a string that looks quite similar to the fishing line, so that's why I thought that it would work. But it turns out after all the experimenting that my hypothesis was wrong, and that the copper wire worked the best, because a general violin string is actually made of sterling silver, and copper wire and sterling silver are about the same material.
My name's Austin Liu.
And my name is Jerome.
And we're both from Maple Creek Middle School. And our project, it's about boredom and the perception of time. So what it is it's about how our brains perceive time when we're bored.
And so this would be the case, for example, in math class at school. Let's say you really dislike the topic, and so you want this to be over with as soon as possible. And so there's 25 minutes before lunch, and so you're trying to stay through the class as quickly as possible, and so you think it's been 25 minutes, but it's actually only been 5 minutes, and that's just your brain overshooting the time or overcalculating how much time has actually passed because you dislike the subject.
So what we did is we have 3 test subjects, and we put them in an isolation room for what they think is an hour. So whenever they believe that it's been an hour, they tap out, and we see how their brain perceived the speed of time.
And we did 4 different tests of this for the subjects to see their brain performance before and after going into the room. And so we found a decrease in reaction time and verbal memory for all of the subjects, which was very interesting. And we think the reaction time, why it decreased, was because while you're in the room, you don't really react with your environment. It's just you consciously sitting in a room thinking about how much time has passed and stuff like that.
My name is Iris. I'm Ella, and we're from Maple Creek Middle.
Okay, so we did our project on why milk is not a significant source of calcium. So for our experiment, for 15 days, we put an egg in 1 cup of milk for 10 days. At the end of these 15 days, we dropped a milk egg and a regular egg from a 1 meter distance. The result was that the milk egg actually broke more than the regular egg, so that kind of proves that milk is not really a good source of calcium.
Milk has a really strong acid that takes the strength from your bones, and it actually increases the number of fractures you can get, and you have a higher risk of breaking your bones.
Okay, hi, my name is Ben Holmes. This is my partner,
Gregory Scott, and we're here from Millard Middle to show you our project.
Our project is named the Scariac. It originated after Grant Thompson, known as the King of Random, who is very well known on YouTube.
So our project allows us to regulate how much power any appliance is receiving.
So in our case, we are using a common household drill, which we can regulate to go as slow or as fast as we want.
The way the project works is that in our water we have sodium hydroxide, which allows the water to become more conductive. When the 2 electrodes are in the water, the electricity passes through the water, but as it passes through, it loses integrity. The closer the electrodes are to each other, the less distance it travels, and the stronger the electric current is.
Hi, my name is Sophia, and I'm from Traditional Learning Academy. And the project that I did was how much lipstick or lip balm you eat in a year, and is it harmful? So what I did was I bought lipsticks and lip balms, and I wrote down the ingredients, and I looked up at the ingredients at the EWG Skin Deep database. You write down the ingredients, and it's going to give you the function, the risk rating, and the risks. So what I did was I weighed the lipsticks, I put it on, and I wiped it off, and I weighed it again and did it that 3 more times. I had 3 other testers do it too, and I averaged up the total, and the average amount is 11.6 milligrams. A 12-year-old girl who weighs 50 kilograms would have to eat about 32,500 milligrams of BHT to be harmful, which is about 1,000 lipsticks a day, and it's impossible to eat 1,000 lipsticks a day because you'd get sick in the meantime, and also because you'd have to pay a lot of money to get the 1,000 lipsticks.
I'm Stefan from Traditional Learning Academy, and my project is about my shoes untying. So a few weeks ago, some scientists from the UC Berkeley Mechanical Engineering found out how shoes untied. First, the impact of your step loosens the knot. Next, the swinging of your shoelaces unties it. I both want to test their theory and make my shoes stop untying. The first thing which I tried was tape. It was supposed to hold down the knot, but it was just hiding it, and the impact of the step loosened it, as the graph shows here. The control means the one with no modification, and the experimental one means the one with one of those 3 modifications. Second, I did magnets. When there's a lot of impact, it comes apart, and when there's a really hard impact, these come off, and extra weight makes more swinging. Last, I tried Velcro. It worked really well. It works so well that it's even hard to take on and off. And what I found out about it is that Velcro works a a lot better than anything else, and that they were wrong. The impact is what really makes the difference.
Hello, my name is Faith.
And my name is Aisha, and we're from Coquitlam Middle.
So for our project for the Science Expo, we decided to create an app.
This app includes a list of 70 plus diseases, which include symptom and causes of each disease.
Our project is named Medpedia because a huge part of it, as Aisha said earlier, is an encyclopedia of 70 plus diseases.
We dubbed it Medpedia because it's sort of like a mix of a medical journal and an encyclopedia.
Which is exactly what our project is. So in our project, we looked at seeing if people would actually use our app, because that's important, people using our app. We also looked at if people would think our app is creative, and if we could educate people and maybe stop the number of people dying from these diseases they're not even aware they have each year.
Yes, what sparked this idea actually was our passion for all of those people that go undiagnosed and suffer and are affected from it daily. People even die from diseases that they weren't aware that they had.
Our app took roughly 2 months to create. The first month was spent planning it, and the second month was spent actually creating it. Our app was created on an app called Apper, a free app we found online that will allow you to create any app looking professionally.
Yes, thank you.
Thank you.
Hi, my name is Sydney and I'm from Moody Middle School. I did my project on bending water with static electricity. So basically I used 3 different liquids and 3 different balloons. The balloons were 3 different sizes, 1 big, 1 medium, and 1 small. The 3 liquids I used was milk, water, and Coke. With milk, it bends the most out of the 3. And if I use the biggest balloon, it would bend more than if I use the smallest balloon. With water and with the Coke, it actually didn't bend at all, because when the water, the molecule looks like this, and when you bring the negatively charged balloon near the water, the 2 electrons are attracted to the negatively charged balloon, and when you bring the negatively charged balloon near the water molecule will actually turn towards the negatively charged balloon, and that's what causes the water to bend.